Okay, this time I need to solve for x and y. So it says state the relationships involved. There will be multiple. Assume all lines that seem parallel are. So on number 6, I have an expression with y, another expression with y, and one with x. So we're not setting up a systems of equations like we did in last class's warm-up. We're just going to deal with the y's first and then go back and use y to find x. So I'm going to list out these steps. First, let's look at our y angles, here and here. What are their relationships? Vertical angles. So vertical angles are congruent. So I'm going to set those equal. 6y plus 14 equals 11y minus 26. Subtract 6y on both sides. 11 minus 6 is 5y. Drop everything else down. Plus 26 on both sides. 14 plus 26 is 40. Divide both sides by 5, so y equals 8. Now, I'm okay if one's like this. You start to show work inside the picture instead of inside the box because sometimes that just makes more sense. Okay? So I'm looking to find x now. Neither of these angles have a direct relationship with x. So I have multiple options. If I plugged 8 in for this y, then I could say, well, this angle that I'm pointing at and this angle that I'm pointing at are corresponding, and then that leads me to linear pairs. Okay, if I plugged it into this y, then I could say that this angle and this angle are alternate interior, and then I could talk about linear pairs. So I have a couple options. Do we have a preference? Corresponding. Okay, so we'll plug it into 6y. So write yourself a little note here. Use answer to find the other variable. That may seem silly. Right now you may be like, well, duh, that's what I'm doing. But if you go back and look at your notes, you're right, Lily, you might forget. How did I get that? So this is a note to yourself in the future. All right, so let's go ahead and plug 8 in for this y. So I have 6 times 8 plus 14. 6 times 8 is 48, plus 14 is 62 degrees. If this angle is 62, then this angle is 62 because they're corresponding. I have a couple options. I could say these are linear pairs, so 13x minus 25 plus 62 equals 180. Or I could save myself a tiny bit of work, and right now I could say 180 minus 62 equals 118. I was able to do that through linear pairs. And now I'm going to set 13x minus 25 equal to 118 and solve. Is it an emergency? Can you wait till we go through these tough ones? Okay. Add 25 to both sides, so 13x equals 118 plus 25, 143. Divide by 13 on both sides, x equals 11. I've now found both variables, and I've stated a lot of relationships. Did you get all that? Okay. Questions on 6. Number 7. There's a lot going on here. When I look at number 7, I see this transversal cutting through 2 parallel lines. This extra segment here is all that is, an extra segment. what it's here for is to cut this angle here into two pieces, not necessarily equal pieces, and it's not necessarily drawn to scale. Okay, so I'm going to start out by looking at my y's because there are two y angles. What do we know about the relationship here? They're congruent because alternate sides of the transversal and on the outside of our parallel lines, the alternate exterior. So I'm going to set them equal. 9y plus 4 equals 11y minus 14. Subtract 9y on both sides. 11 minus 9 is 2. Y minus 14. Add 14 to both sides. 2y equals 18. Divide by 2 on both sides. Y equals 9. Now again, I have multiple options on where I could go to next. Anyone have any ideas? We're trying to get x. Here's our x. The entire angle here for x is what we need to look at first, though. Does that entire angle have a relationship with either of these two pieces?
Oh.
Yeah?
Yeah.
Tape?
Didn't we plug the y back into, like, wouldn't it be 9 times 9 plus 4 then?
Yeah, we're going to plug y back into one of those. So you're saying this one?
Yeah.
Okay, let's do that. So, yes, we're right there. 9 times 9 plus 4, 85 degrees. Dalton, what did you say they were?
They were vertical.
Yeah, so here, both my orange angles, those are vertical angles. So now I'm going to say through vertical angles,
85 minus
yeah. So these two things make up 85 degrees. So I'm going to add them together. 3x plus 28 plus that 63 degrees equals 85 degrees. Combine my like terms. So 3x plus what's 28 plus 63? 91 equals 85. Subtract 91 on both sides, so 3x equals -. Divide by 3 on both sides, so x equals -2. Again, it's okay if our variable is negative as long as when we plug it back in, we still get positive. So 3 times -2 is -6. -6 plus 28 is 22 degrees. So this angle's 22. And this is 63. Does it come back out to 85 if I add them together?
Yeah.
Yes. So I know I've done it correct. Or I've got another hint that I did it correct.
Is this like the same stuff you're doing in honors geometry? Or what are you doing?
In honors geometry, we did some like this, but we also did systems of equations within these types of questions. Last one. Okay, again, we have these two parallel lines here. And then this line would be considered our transversal. So this is an extra piece. Why not? Yeah, I'm trying to challenge you, right? So first we want to look at our y's. So when I look here, I've got this angle that has a y, and this angle has a y. Well, those two pieces don't have a relationship, but this whole thing does. The whole thing does. What is their relationship? They're on opposite sides of the transversal, and they're both on the interior. Alternate interior. If you get stuck on these challenging ones, I really do encourage you to use the highlighter to kind of identify what your angles are. They're congruent. So let's plug them equal to each other. We have 8y plus 42 equals 5y minus 9 plus this additional part here that has a box in the corner, and that tells me 90 degrees. So plus 90. Simplifying on the right side, 5y plus 81, negative 9 plus 90 was 81. Subtract 3y, or sorry, 8, subtract 5y on both sides, so you get 3y. Dropping everything else down. Subtract 42 on both sides, so 3y equals 81 minus 42 is 39. Divide both sides by 3, so y equals 13. I know I'm going a little bit fast through the addition and subtraction, but it's okay. If you needed to plug that into your calculator, that's just another step, and that's okay. So now I know that y is 13. I have multiple options here. Here's what last class wanted to do. They said, well, if this angle here, let's see if I have another. I'll use red. If this angle, oh, you're talking about linear pairs? So you would plug it in here and then say this plus 90 plus this should be 180? Yeah, that's absolutely an option. So we'll either do that option, or we can plug it in here so that these are linear pairs, and then plug this into here because they're alternate exterior. Would you guys like to take option 1 or option 2? Raise your hand, option 1.
I'm confused. I was writing down my-
All right, option 1 it is. Okay, so we're going to plug it in here for y. So we have 5 times 13 minus 9. 5 times 13 minus 9. 56?
Yeah.
Sure.
56 degrees. And this one is 90 degrees.
You have it.
So let's add these all up and say they equal 180 because they are linear pairs.
5 times 13 was 65.
65 minus 9.
Oh.
Don't forget that minus 9 piece. So we have two options. If we know that this whole thing equals 180, and this is 90 and 56, we could right now say 180 minus 90 minus 56 would be this angle. So what's that degree?
What's that angle?
Yeah. What's 180 minus 90 minus 56? Shouldn't be. 34.
34.
So our two options were to say 14 minus 4x equals 34 and solve. Our other option was a lot. It was to say, well, I mean, it's just barely more. Was to say 56 plus 90 plus 14 minus 4x equals
That's just extra.
180. So that was just a little bit more, right? You have one more step to combine your like terms before you get down to this. And that'd be okay. Not necessarily this, but this amount of. Couldn't I have done what?
Speak up. You already said it. Speak up.
Do you have another option?
Yes. I got it.
Subtract 14 on both sides, so negative 4x equals 34 minus 14 is 20. Divide by negative 4 on both sides, so x equals negative 5.